Okay. So, hello everybody. Let me share the screen. I would like to confirm that the screen is working fine. So, as I said, well, buonasera a tutti. This talk is going to be about ways to keep your sanity while developing software. And also, I would like to help you to understand the source of your worst nightmares and learn how to prevent them and avoid them to come and chase you while you are asleep. It is about bringing some sense to software development and also to your life. This is not about psychoanalysis, trust me, but I would say that it is freaking better. So please bear with me, and I hope this is going to be also interesting to you. So let me go with the agenda. I will start talking about software change and what software change means and how it impacts our ability to do things in the application. And also, I would like to get into a little bit more of detail and talk about how to evolve your application, how this evolution is going to be happening and what things you have to keep in mind. And then we will go through 3 very common real world scenarios, and I will end up with a brief recap of what we have seen. So without further ado, let me start with what software change is and what it means for us as software developers. And I would say that sometimes as software developers, we have the perception that most things that we are finding are quite new because they happen to us and because the age of this field of software development is quite recent. I mean, like, it's a very young discipline. But the truth is that constant changes has been a constant in life for a very long time. The main difference between then and now, or between them and us, is that in software, change is a very important and fast change because we are depending on business that require our software to work and to align with their objectives in order to deliver on the business itself. So, believe it or not, in 1974, long time ago, Lehman and also Belady wrote these laws about software evolution that are still quite current. I would say that if you read them now, you would think that this was written like 10 years ago, but it has been almost 50 years, and it has aged very well. When we talk about changes in software, it is important to keep in mind that the software has to change if it wants to be useful to the people that uses it. If it changes, it will increase its complexity. And no matter how you try to change that, some parameters of the change are going to be somehow constant for each given software. And the amount of resources that you put in the organization within some certain limits don't affect that much to the pace of the software that you deliver, to the changes that you are able to produce in a given amount of time. You will try to preserve familiarity of the users with your application, because otherwise they will perceive the application as a totally different one, and then you will be at the beginning of the competition with your competitors, and it is better to have them transition from the previous version into a newer one that is a soft evolution. All these changes will imply that new features are going to be added, so the application will continue growing, and sometimes it reaches to the point that it is a feature bloat in your application. I can give you a very common example that everybody knows, that is Microsoft Office, that although it is a very cool application, it has more features than any other application, and some of them are completely unrelated to the fact of writing Word or writing spreadsheets or whatever. If you introduce changes in your software, the quality, unless you pay special attention to it, is going to decrease, and you want to avoid that. You want to pay attention to that. And in order to have feedback and react to these changes, you want to have these channels that you're using to distribute the software, providing you feedback about how things are happening, if they are happening okay or not, or whatever. So I would say that you have to go and consider these laws. And in the case of maintenance, which is one of the two things that we consider software changes. So when we talk about maintenance, it's probably the less sexy things of the changes that we introduce in our software. We're mostly repairing the things that we did wrong. Defects that have been reported by the users who are using the application, or maybe even the QA. Also, if we have any tool that is able to detect the crashes and to report them back to us, we will be trying to fix those, improve the performance if we notice some complaints about how the application is performing at this moment, and adapting to environment changes. I mean, like to say that when an application that wasn't using permissions before and Android introduced them, we had to, as owners of the application, we have to take into account permissions in order to make our applications to adapt to that environment. The amount of effort that we put into maintenance, let's be honest, it really depends on the initial implementation. It depends on other factors, but the quality of your implementation is key. So if you have bad software, you will spend a lot of time in maintenance. If you have spent some time devoted to the quality of your software, you will spend less time on maintenance. Not zero, but less time. And no matter how you do that, you are going to be able to impact on the rating of your application, which is very important for us. So if you don't spend any time on maintenance, or if you do it poorly, your rating is going to suffer for that. And if you do a great job and you solve issues very, very fast, you're also going to be rewarded by your users. So these maintenance that we have talked about, it actually can be grouped into 4 different types of tasks, depending on whether you react to things or you try to prevent them from happening, and depending on whether you are trying to correct things or to improve things, then you have these 4 different types of maintenance. So if you want to take advantage, foresee what the problems are going to be and fix them before they have been reported by your users, you are talking about preventive maintenance. While if your users have already noticed those, we're talking about corrective maintenance. Same thing happens about the enhancements. If you foresee situations and you react to those before they happen, you're talking about perfective maintenance. While if you are reacting to complaints that the user have about the way it behaves, then we're talking about adaptive maintenance. But in any case, it doesn't matter which of these groups of maintenance that we're referring to. Maintenance is hard. It's not only hard, but it's not sexy. So what do I mean by that? It's hard because when we are trying to solve the bugs of our application, we want to be sure that we are considering the things that we didn't consider in the first place. We're talking about edge cases, or at least things that we didn't have in mind when we wrote the application. It's not only that, it's also related to the fact that maybe we have not put a lot of effort into making our application maintainable, which means that the effort that we have to do in order to introduce the changes that will solve the problem is huge compared to have them done initially. And let's be honest, it is boring. It is hard to tell anybody, oh, I solved something that should have been working from the start and get a congrats out of that. So maintenance is probably not the thing that we're looking for here, but it's important because we're talking about debugging, and debugging is hard. Debugging is, as I said before, we have to keep in mind that the effort that debugging requires, probably also it is your experience, is harder than to write the code for the first time. So Brian Cunningham, who I believe knew a lot about code, he was one of the C creators, always said that it is harder, and it will, if you write the code to the best of your abilities, then you are not able to debug it yourself. But there are things that you can put in place, best practices that you can put in place in order to avoid those problems. And I'm talking about doing pair programming. So you know that it is not only you who understand the code, but your colleagues, and that it is clear to both of you, and that it can also be shared with others. Same thing with pull reviews. I mean, like if you have a pull request and people have to approve that, then it is easier to confirm that the code is doing what it should be. And same thing with having tests. If you have tests and we introduce some mistakes, we will be able to catch them easily. And if we have this testing as part of our continuous integration pipeline, then we will be catching them as soon as we produce them, and we will be able to react to them easier and with less cost to the organization. But what we were talking about here was the fancier thing of this evolution, the things that we, in which we introduce major changes, new features, and things that may affect the structure of the application, or even the way the information is structured for the user. They might be major changes. Sometimes they are not perceived by the user. They are transparent to the user. But in some cases, it even includes the solution to some of these maintenance issues that we were mentioning before, as part of the changes themselves. In any case, because of the nature of these changes is bigger, we will have deployments that require more effort, that require to pay more attention to them, because we want to be sure that we do these deployments properly. And yes, we want to have this deployed, and the impact of these deployments and these changes will be depending on when the changes are introduced and how different the new version is from the previous version. If we introduce changes later in the process, long after the design was done, long after the planning, and probably it will impact more our development, because we will probably violate some of the assumptions that we did initially in order to do that. So the sooner we introduce these changes, the more organized we are, the better. But let's be honest, it's impossible to foresee everything that is going to happen to your application. So our goal here is to evolve the application, to keep our users happy, to continue providing the business with value so they can do whatever our business is doing to get some income and pay my salary. But at the same time, we want to control complexity. We want to maintain the complexity under control so it doesn't become an issue to us. So one thing that we should take into account when doing this complexity control is how these changes can have different kind of risks. So if a change is minor in scope, as we were saying before regarding the maintenance ones, then probably the risk is tiny. I mean, it's fixing some stuff or adding a minor functionality. For example, it will add the functionality to make all caps some text. Well, it is there. Chances of this backfiring on you are small. However, there are some changes that have more entity that are more important for your application, and that will have a lot of impact if done all together at the same time, but that they can be applied progressively. So you can change your application a little bit, and then another little bit, and then progressing till you eventually have finished the whole change. That is a good scenario for risk control. There are other changes that don't allow that. And let me give you an example. Let's say that you want to use a different backend, which is using a totally different server, different type of persistence, whatever, for your application. Well, I mean, you cannot use this new backend for one view and the rest of the views will be using the old backend. Probably the data would not be okay, it would not match as what you see on the first screen with the others. But that is part of the nature of the change. So when you do that, it will be an all or nothing change. So you will have to either go with the previous implementation of the backend or with the new backend, and you will have to switch from one to the other. And after that switch, every user will be using the new backend. That is far more risky. And the biggest risk, from my perception, is when you try to do a big bang rewrite. And that is very common among software developers. We see something, we believe that we can do it better, we don't like the way the code is written, so we decide that we're going to rewrite that ourselves. And okay, so we start doing that from scratch, not using the original version. We read from it, we try to learn from it, but we rewrite the whole thing. Generally, that's a bad idea, and that is very risky. But these things that we were mentioning, these progressive risks, have been a problem for years. So we have learned through the years that we could organize our processes in order to minimize the risk that we are accepting by developing software. So in the traditional software development lifecycle, there are 6 phases to produce an application. So the first phase will be planning, then you will have the analysis, then you will design, then you start coding and implementing all the stuff that you need to do. Then when the application is ready, you will deploy it. And finally, it will be under maintenance, and this maintenance will take care of all the fixes that the application requires. But this is a big waterfall project, so it from the beginning to the end, the amount of time that it goes on is very long, and chances of things changing while you're in the process of creating this application are huge. So that's why these waterfall projects were most of the time doomed. What most successful, if not all successful companies that develop software nowadays do is to implement some kind of agile mechanism. And there are different alternatives, but the important thing here is that you iterate through this loop of 6 phases, and so you create shorter iterations that allow you to keep control of this loop. So you will repeat as much as you need that, but the amount of time that you need to plan things that you can implement in a number of weeks, let's say 2, 3, 4, however long your sprint is reduced. So the planning should be short, the analysis should be short, the design should be short, implementing that should be shorter, and deploying it should be trivial because it's not that different from the previous version. Maintenance is also in the loop, and you will take care of that all the time. So even though that sounds like a better idea to do these progressive changes, there might be reasons why you want to retain all these new features and to release them at once. And the main reason for that is an economical reason. Sometimes your business is not on the services that your application uses, or on the goods that your application sells, or on any other thing like that. Instead, it is on the software development itself. And you want to monetize each of the changes that you produce from the users that consume your application. So you, instead of doing progressive changes to your users and offering them a subscription, which, let's be honest, is not very popular, you prefer to create a whole new version and probably make an in-app purchase for the new features, or maybe a whole new application with these new features with some ability to do the transition from the old to the new one. Okay, so let's talk about your application and how to evolve it and where you can be and what does this mean. So let's say that this could be a very simplistic way of describing the scenarios in terms of the status, development state of your application. I could say that an average status for many applications is that they have some Java still, but they, particularly those that started with Java, but they mostly use coding. They're using fragments and activities were required, but mostly fragments. They do have some architecture, Android architecture components in place, even navigation. They're using some persistence, probably room. And in some cases, they are using some dependency injection framework, but some of them are using simpler solutions like the service locator. In any case, depending on your application and how it has, when it was developed and the amount of effort that you put into that, chances are that you have one of these applications that is still mostly in Java, that everything happens in the activities, there are no fragments, the code is very coupled, and that you're using basically massive view controllers as your architectural solutions. The persistence is done with SQLite, and the dependencies are provided by singletons. You don't want that. You want to go to the other extreme where everything is new and shiny, and the solutions provide you with more flexibility, with more ability to grow and to continue in the future. So what you want to do is to have these transitions from Java to Java plus coding to only coding, because that is the future for us. Transition from activities to introducing some fragments, and then maybe go into a newer paradigm of user interface implementation, which is Jetpack Compose, reactive, very nice, declarative in the way that the activities of fragments cannot be. You probably want to have some architecture, and if you have nothing, the basics could be good, but if you are already there, you want to go into having other components that can be reused, that can be abstracted away, and that can be replaced. The ones that make sense for your project, not the ones that others tell you that you should have. But this reusability is good, and this ability to replace parts is also good for your testability and for your ability to grow and improve the quality of your application. If you want to improve your persistence and want to go with a solution that allows you to be offline first, and that without having to worry about communicating with the cloud, allows you to do this synchronization with other devices, other operating systems, and that you use native persistence with objects without any SQL, then you can decide to go to Realm. And that also would be a lot of progress from your previous implementation. And same thing about your dependency injection. If you were doing nothing and you were using singletons, Server Locator is far better. But if you're using some framework for dependency injection, be it Dagger 2, which, let's be honest, again, this is not the easiest way. You probably read about it and you got stuck at some point in the description of the coffee maker and all the stuff. Hilt is easier. I would give that to it, but coding and coding are even easier from my point of view. So if you are on the shabby part of this description and you want to go to the state of the art, you probably might be thinking, hey, why should I spend all this effort to do all these changes and move from my shabby application into this shiny and new with everything included application? Well, that would be a rewrite, and this would be a big bang rewrite. So you would be starting from scratch and writing this new application. But let me tell you that, as I said before, this is not a general, this is not a good idea. So why I would say that big bang rewrites don't usually work? Well, the thing here is that you have your application, the application that you've been implementing for a long time, and that has some features, some nice things, but a lot of things that you would like to improve, some bugs that you don't like, and some things that cannot be changed easily. So you decide to start and you create your new application from scratch. And this new application, you're going to start from fresh, and you're going to use your best knowledge and best practices to plan, analyze, design, implement, and do everything right. You promise yourself that you are going to do TDD for every part of the code. You promise yourself that you won't allow a code that is not a state of the art. You promise yourself that you will eat the vegetables every night. But the truth is that this is not what happens usually. You do your best and you will make mistakes, as any one of us. The thing is that while you're doing these promises and while you're devoting all this time to write your application again from scratch using the new best practices that you have learned, the old application is still running and is still being used, so users find bugs on it. And those bugs that are found should be fixed. So you should also pay attention to the old application. Not only that, if this is in some way relatable to your new implementation, you should be able to ensure that this bug is not going to happen in your new application. Otherwise, it doesn't make any sense to do the change. Now, bugs is one thing, but the business is also continuously changing, and they may have new requirements that are urgent and that it cannot wait for the new application to be ready, because normally the application that is written from scratch is not ready immediately. It takes a long time to get the application ready. So you will have to do these changes, do the planning and implementation in the old version. And not only that, you will have to think how to bring these new requirements into the application that you are already planning and design, or maybe already implementing. So that is another challenge. And the code that you're writing is going to contain bugs, not the ones that were in the other code base, but the ones that you introduce because we make mistakes. We're humans. And these bugs will have to be solved, and debug later. And the truth is that these two applications have very different evolution paths. So by the end of this process, they are probably quite different, and it is challenging to move from one to the other. Not only that, the promise of writing this, it doesn't matter how long you estimate that this is going to take, it will always take longer than expected. Example, so far, that it took less to rewrite the application from scratch. But if you know any, please let me know, because I will be glad to share it with other people in future talks. And once you have everything ready, you have to give a jump of faith. I mean, there is also this big bang deployment that you have to do, because you have to switch off to avoid users to use the old application and have them in the new one, which is challenging. And as Joel Spolsky, who is a very well-known developer and very respected one in the community, said, the single worst strategic mistake that any software company can make is big bang rewrites. So there are exceptions, though. You may have an application that is so simple, so trivial, that writing the full application from scratch may make sense, because it was a prototype, something that was not going to be used, still tiny. So you schedule a couple of weeks and 2 months later, you have the application fully rewritten. Also, there's another situation that may make sense here, which is if you are going to have an application that is so distant from the destination that you want to achieve, that is probably very hard to get from one to the other through changes. It would take you your whole life. Let's say that you have a COBOL application running on the mainframe and you want to get from that a mobile application running on Android. That's stretching it a little bit, but you know what I mean. Very, very different. So probably the amount of effort that you're going to put into that is far more than rewriting it. So, well, maybe that's also a good scenario for that. But in most cases, I would recommend refactoring. And refactoring means that you are going to change the internal structure first in order to make easier to introduce the changes later. But while you change the internal structure, you must ensure that you don't change the behavior. That is key. Because if you change the behavior, you are not refactoring, you are modifying the software. And you will do this through small steps, because you want to ensure that every step still behaves exactly as it was behaving before. And if there is some kind of issue, you will want to be able to detect that as the sooner the better. The important thing here is that you keep in mind that you shouldn't allow yourself to be in the middle of the jungle. And by that, I mean that I have been trying to watch the screen of some developer and saying, so why didn't you commit? Well, I did this change, I did this change, I did this change. Now I'm here. And if I go back, I will be losing all this work. And if I don't know how to continue, I have a problem, but I don't know how to sort it. And that means that your changes, the things that you are committing onto the repo are too big. Try to make them as small as possible. Well, we talk about refactoring, there is a catch-22 here. I mean, you are trying to refactor, and by that we say that we mean don't change any behavior. But in order to verify, to be sure that we're not changing any behavior, we would like to have tests in place that allow us to confirm that no change has happened in the behavior. The thing is that many code bases, the ones that we're talking about, the ones that you want to evolve, don't have as many tests as we would like. Some of them don't have any. So the code is not very testable, and we don't have the test, and we cannot verify that. So we change the code to introduce tests without changing behavior, which is not easy to verify because we don't have the test in the first place. So again, try to be mindful about that. But you have three possibilities to solve that. You may want to use a standard refactoring. By standard refactoring, I mean there's a book, there are two actually, because there's version 1 and version 2 by Mvvm Works regarding refactorings that you can use that are recipes that explain how to go from one situation to another situation following very well detailed steps that will take you to code that is functionally identical to the previous one. That is good, but this is just like knowing how the pieces move in the chessboard. It's very important that you know how to do that, but you need some additional strategy and good understanding of all the process in order to be able to go from A to B using those movements. You need the movements, but you need something else. The other thing that you can do is to find seams and pieces that can be isolated. And this was introduced by Michael Feathers in his book, Working with Legacy Code. And basically tries to isolate parts of the code, smaller parts, and work with those instead of the application as a whole. Still challenging, but much easier than trying to solve the thing as a whole. And finally, I'm going to give you another option, which is take the risk and refactor without the test until you can introduce them. Probably you are saying, "Ma que cosa?" This Spanish guy was telling me, please avoid risk, control risk, and now you're telling me take the risk and refactor. Well, let me tell you that you were there first. I mean, like you were into this situation before thinking about it. You were going to change things without having to worry about what was happening. So what I'm saying is, instead of doing that, now you have a goal in mind that is to introduce the test, and your refactorings are trying to address that situation. If you can afford that, if the risk is acceptable for you, go with it. In any case, my advice is to not to cheat yourself. I mean, you were in this situation, you are now in the situation that is hard to deal with because you or your team or whoever was there before didn't introduce the test. I know it wasn't you because you were caring about this, but these ugly people that didn't pay attention to introduce tests in the first place. Don't extend the pain any longer. So let's go through the 3 examples that I wanted to mention briefly. And these are 3 real-world examples and are based on the table that I mentioned before. The first one is that I want to introduce the architectural changes that I was mentioning before. So I want to go from the worst situation, which is having the spaghetti code with everything coupled, everything happening in a massive view controller, having intents, and I want to move on to at least architecture components and hopefully onto using Jetpack Compose later on. So how do I do that? Well, the first thing that you have to keep in mind is how Mvvm works. And that is very important. If you understand how it works, you will be able to do the thing reducing the risk involved. So you should know that the role of a view model is to accept events from the view and to provide them with meaning. I mean, like it will translate the user has tapped on this button with it has created another instance of this object. That is the role of the view model. The second thing that the view model does is to provide the view with a description of how the view should be displaying the information. Not only the text or the colors, but also the position of some controls or anything that is relevant in terms of things that can be changed in the view. The view will be observing those changes and reacting to the changes and updating itself. So if you know that, the first thing that you have to do is go and choose probably the easiest view that you have. Identify the events that this view sends to the view model, or should send to the view model rather. And also identify the things that may change when displaying this view. Does it have a text that change? Does it have some sigbar that can be updated? Well, anything that might be relevant to your case. And then you can create a new class that will be the view model. This new class will have one method for each of the events that the view is going to use. And you can invoke these empty events, empty at the moment, so you know that everything is wired. You can introduce tests to verify that this view invokes to each of these events when it requires to do so. And then you will be moving code from your view onto these methods, into the related methods, until your view is mostly empty. The only thing that you have to do additionally is observe the changes on the properties and change the display based on that. But that, thankfully, that is a single function that takes care of all these properties. That is why Mvvm is easier. So when doing that, you will be able to have this new view model detached, and you will have a dumb view that is something good. Having a dumb view is not something that you should avoid. And that will allow you to go one step further, and by using the same view model, you can replace your traditional SDK views with Jetpack Compose views, okay? That change can be done progressively. So you can go from an application that has everything coupled, no architecture, into a single activity that does this properly and spread it through the whole application eventually. And that, in terms of controlling risks, is good. The other thing that you may want to consider doing is, as we were saying before, changing dependency injection and using a framework for that. So in this case, let's assume that we were doing nothing before that. And what we're going to do is to do the changes that are required for that, to introduce these changes easily. So the first thing that you have to do is to make dependencies injectable. That means that everything that you need in a framework, in a fragment, you will have to be able to inject it via property, not via constructors, because you cannot control the constructor of a fragment. Everything that you need in a view model, you will have to be able to inject it, and so on. And every time that you catch yourself creating an object, you slap yourself on the hand and promise yourself not to do that again. The important thing here is that after that, everything that is used within a class is provided from the outside. Then we will be using a service locator pattern in order to provide the dependencies. So we will use the application subclass. We will create a method for each of the dependencies that we have to provide. And the views will be using these methods in order to inject themselves with this context. Not the best option, but easier than other options. Finally, the other thing that we can do is once we have this injection, we can go all the way into using one of the frameworks and create a module, which is a common terminology among all of them, for one of the views. And then progressively, eventually, we will be getting the rest of the views. The truth here is that you don't want to use one mechanism for one view and another for the rest. So once you start doing this migration, you will have to commit yourself to finish it as soon as possible. But other than that, you have the ability to do this progressive change that we were mentioning before. Finally, my third real-world scenario is if you want to migrate from SQL all the way into 21st century persistence. So if you want to have an application that is offline first, that you don't have to worry about whether you have connectivity or not, but that it will also be able to synchronize with the cloud or with other devices should it need to. So you want to go all the way from SQLite to Realm. And in order to do that, you have to follow these other steps. You have your persistence implemented, let it be SQLite, but it could be any other. And the first thing you have to do is to define an abstraction. The abstraction must not be leaky, but should contain all the functionality. What do I mean by that? Well, I mean that it should not define inside of the abstraction, in the methods of this interface, anything that is especially related to the persistence method that we are using. And it is pretty common to take into account the CRUD operations, so create, read, update, and delete, but usually people forget about all things that are also relevant, like notify me if things change. So you should provide all the methods that are required for your usage of the persistence. Once you have that, what you do is to refactor your implementation of the persistence so it uses the abstraction instead of the persistence itself. So you will be using this abstraction that you have created in order to use SQLite. And finally, we will implement the same abstraction, but with the new persistence, with Realm instead. So what you will be doing is to move from the old persistence to the new one, just injecting a different object. And the rest of the code will not have to worry about that. But the truth here is that this is an all or nothing change. The risk is higher because you cannot store half of your data in SQLite and another half on Realm. It wouldn't make any sense. So you have to pay special attention on how you do this change and be quite sure that everything is ready for the moment. There are things that you can do in order to do that when you're creating branches. So basically, if you're using Git flow, you create a feature branch, and implement the changes, and you merge them when everything is ready. But if you want to be agile, probably a better method is to use trunk-based development and create a feature flag. I gave a full talk about feature flags at the Droidcon London, and I have code, I like coding for that, which I couldn't fit in here, sorry. But using this feature flag, you will have both versions of the code. You can choose for different collectives what you want to use. And at the end, you will choose one and clean up the rest of the code. Much better, much more agile. So let me recap. I believe that being agile has far more implications than just the processes. You should do development in an agile way. And that means that your code should be evolving incrementally, and that your risk is also minimized by that use of incremental modifications. You will benefit from the things that I have mentioned here. I mentioned a few: feature flags, pair programming, pull request reviews, etc. And if you're going to do an evolution of your application, I would recommend you to use refactoring as much as possible. And when you do that, make the changes incremental and rely on your version of version control system, because that is where your changes should be reflected. And deployment should also be incremental if possible. Sometimes it cannot be, but I would recommend using feature flags and having different values for the different collectives. And finally, if you can, allow yourself to go back. So if something goes wrong, you can go to the previous situation. That is not something that you cannot always do, but if you can, do it. Finally, introducing these evolutions require a good understanding of the code that you're going to write, of the implication of the evolution that you want to introduce. But even for complex evolutions, it is possible to approach them with some risk control. And I hope that this is what I share with you here, that this control has been helpful to you, and that you can put that into place in your application. So, grazie, thank you. And if you have any questions, I will do my best to try to answer them.